Welcome to another video, dear students. Today in this video we will be learning about the different types of isomerism. What are isomerism? So let's start here. Now isomerism, they are basically of two types, structural and stereo. These isomerism, about the structural isomerism you have learned in your class 10, just the basic. Now today we will be learning about the deeper aspect of this isomerism. Structural isomerism, they are classified as chain isomerism, position, functional, and metamerism. And stereoisomerism, they are classified as geometrical and optical. About this stereoisomerism, we will be learning in our 12th. But here we have to learn about the structural isomerism. What are the different structural isomerism, namely this chain isomerism, position isomerism, etc. So let's see one by one. The first one is chain isomerism. Then in case of chain isomerism, what happens? The formula remains the same in all cases, as you remember the definition of isomerism. Isomerism means when two compounds, they have the same formula, but their structures are different. Then those type of compounds, they are known as isomers, and the phenomenon is known as isomerism. Then in case of structural isomerism, what happens? The molecular formula, it remains same, but the arrangement of the carbon, it is different. You can see the example here. Three examples are given. In all the cases, the molecular formula is same for all of them, that is C5H12, but the arrangement of these carbons, you can see they are different. Here you see, in all the cases we have 5 carbons, but these 5 carbons are arranged in different ways. So this type of phenomenon is known as structural isomerism, means the number of carbons being the same, but the structures are different. This is structural isomerism. Next comes the position isomerism. In case of position isomerism, the molecular formula remains the same, just the position of the functional group or the substituent atom is different. Means you see, here this OH, it was present at the terminal carbon, but here in this case, the OH is present at the middle carbon. So this type of isomerism, it is known as position isomerism. Next comes the functional group isomerism. Here what happens? The molecular formula remains the same, but the functional group, it becomes different in both the cases. See an example here. Here the molecular formula, it is C3H6O, but the functional group in both the cases you can see here. Here it is a ketonic group because this carbon is bonded to two carbons on either of the sides. But in case of this aldehyde, you see one side is bonded to carbon, the other side is hydrogen. So here the molecular formula is same, but the functional group is becoming different. So this phenomenon is known as positional functional group isomerism. Next one is metamerism. This metamerism, it can be seen in case of this ethers. Here what happens, that the number of carbons on either side, it is different. You see the total number of carbon in both the compounds, it is 4, but on one side we have 2 carbon in this one, and on the other side we have again 2 carbons. Total we have 4 carbons, but here you can see on one side we have 3 carbon and the other side we have 1 carbon. So here what happens, this type of isomerism, it arises due to the presence of different alkyl chains on the either side of a functional group in a molecule. They are known as metamerism. Next comes stereoisomerism. Here what happens, about this stereoisomerism we'll be learning in class 12, but just the basic definition what we need to know here is that these compounds, they have the same constituent of the covalent bonds, but their arrangement in the space is different, and this special type is known as stereoisomerism. And this stereoisomerism, it is classified as geometrical and optical. Geometrical means the relative positioning is different, and in case of optical isomerism, it is something related to mirror. We'll be learning this one later. Here now comes the concept of organic reaction mechanism. Now in any reaction we have two things. These two things, the first one is the original molecule which will be reacting. The next one is the attacking reagent with which this will react. These two react to form an intermediate. Intermediate means just before the product, one stage is reached where the it is not finally the product also, and it is also not the completely the starting product, means in between the starting product and the final product. So this is known as an intermediate. Then finally it yields the product where some byproducts are also there. Then in this whole mechanism, this organic molecule, means the substrate, the reagent, and the product, they have different roles, which is given here, you see, means they are characteristic. Then substrate is the reactant which supplies carbon to the new bond and the other reactant. Means substrate will be that substance which will supply carbon, and in some cases you will see that both the reactants and also the reagent, both they are supplying carbon. Then in that case, the choice will be ours, that on the molecule on which we are giving an attention, that will be taken as a substrate. Then next comes the reaction mechanism. Then certain reactions are there which do not take place in a single step in organic chemistry, means they take place under many steps, and these different steps, they are given in different sequence. Then that sequence of the transformation of a substrate to its product, that is known as reaction mechanism. Now, in case of reaction mechanism, two things basically play the main role, which are known as the nucleophile and the electrophile. About that we'll be knowing, but now any covalent bond that can break in two ways, then this covalent bond, it can break in two ways, where they are named as heterolytic cleavage and homolytic cleavage. Now as the name suggests, heterolytic means something difference will be there, and in homolytic something similar things are there. Then let us see one by one. In case of heterolytic cleavage, what happens? The bond breaks in such a way that the more electronegative atom will take away the electron. Means if the bond is breaking, then in that case one part will bear the negative charge, the other part will bear the positive charge. Then such type of breakage when it occurs, or cleavage when it occurs, that is known as heterolytic cleavage, where one atom will be having a sextet in its electronic structure and a positive charge, and the other will have the valence octet with at least one lone pair, and that will have a negative charge. Means one will be not completely satisfied, and the other one, it will have one more electron than actual of its. Next one is the homolytic cleavage. In case of homolytic cleavage, what happens? The electrons which were shared in the bonds, they are equally taken away by both the atoms. Then how it occurs, you see here in this case. What happens here in case of homolytic cleavage, you see the bond, it broke from here. This bond has broken. Then we all know that in any electron we have two bonds. In any electron we have two bonds, or sorry, in any bond we have two electrons. Then when the bond breaks from here, this one electron is taken by this atom and the another electron is taken by this atom, and in such case no charge separation is there. We get a free radical. This type of compound which is having a electron on it in the free state, they are known as free radicals. But in case of this cleavage, in case of this heterolytic cleavage, what happens? The both the electrons, they are completely taken by one atom. Both of the electrons, they are taken by one atom completely. So one bears a positive charge, the other bears a negative charge. Now in organic reactions, they mainly proceed, means they can proceed by any of the means, but when they proceed by this homolytic fission, they are called free radical or homopolar reactions, and if they proceed by heterolytic fission, then they are known as polar reactions in that case. The next ones are nucleophiles and electrophiles. Now, what are nucleophiles and electrophiles? Then a reagent which brings electron, they are known as nucleophiles. Now, what are nucleophile? I'll tell you. This is made of two parts. One is nucleus, the other one is philic. This philic means loving. Philic means loving. And nucleo means nucleus. Then nucleus are positively charged. Then those part which are negative and they are coming to the positive, they are known as nucleophiles. These nucleophiles, they are nucleus seeking or nucleus loving. Then a reagent which brings an electron pair, they are known as nucleophile, and the reaction is called nucleophilic. And in case of electrophile, what happens? A reagent which takes away electron pair, they are known as electrophile, and the reaction is known as electrophilic. Then during a polar organic reaction, a nucleophile attacks an electrophilic center of the substrate. Similarly, the electrophile attacks a nucleophile center, which is the electron rich center. Electron rich means which is having excess of electrons. Now, electron movement in case of an organic reaction. Now, just you need to know this basic things because the in class 12 these all things will be required. What is there that we all know that there are two types of bond. There can be double bond or a single bond. Then whenever this single bonds they are fixed, they cannot move from their position. But this double bond they can move. They can move from one position to another. Then they are then this movement, the electron movement, it can occur in these three ways. Means either the bond will transfer to the adjacent bond position, or they will transfer on the atom first. Then one bond consists of two electrons. Then these two electrons you can see here, it came here. Then once again these two electrons they can go here and they can form the another bond in this way. Means this bond, the double bond it can move, but the single bond it cannot move. Single bond is fixed, it cannot move from its position. Next comes this electron displacement. What are the different types of effects? Then there are two types of effect mainly: resonance effect, inductive effect, and one more effect is there, that is mesomeric effect. Let's see about them once. Resonance structure. Now, what is resonance structure? Resonance structure means what we have seen, that suppose if we are forming a bond of water, this one, then it is seen that the position of these electrons, this is not fixed in every case. These electrons, they are rotating from one position to another. They are rotating, they are changing their position. It is not in case of water. I've just taken an example. Then this type of structure, they can be represented basically in two or three ways. So such structures are known as resonance structure. For example, we have benzene. In case of benzene, we all know that this is the structure of a benzene. In case of benzene, we have six pi electrons, six double bond electrons, and three double bonds. So this same benzene, it can also be represented in this way. The same benzene, it can also be represented in this way. So these two structures are for the same compound. So these structures are known as resonance structure. Means a single molecule, a single compound can be represented by two structures. These structures are known as resonance structure. Now, resonance structures are hypothetical, means it is not actually seen, but they are assumed to be of this type. Next comes the following rules are applied while we write the resonance structure. They have same position of the nuclei and same number of unpaired electrons. Means if in case of benzene I made this one, if I am writing it for a benzene, if I am writing for a benzene, then in a benzene if six carbons are there, then the resonance structure, it will also have six carbons. It will also have six carbons, and the number of double bond, it will not change. Means number of double bond, just the position will change. But here also we have three double bonds. Here also we will have three bonds. So this type of structure, they are known as resonance structure, and these are the two properties for writing the resonance structure, means how they are written. Oh, and resonance effect, then resonance effect is defined as the polarity produced in the molecule by the interaction of two pi bonds, or between a pi bond and lone pair of electron present on adjacent atom. There are two types of resonance. One is positive, the another one is negative. Positive one is known as plus R, negative one is known as minus R. Then in case of positive resonance, what happens? The transfer of electron is away from a substituted group. These are all things we will be knowing once the class opens, because through this it is not possible. We will be conducting some Zoom classes where we will be looking at them all one by one, that what is this positive resonance. Suppose if this is my benzene. And in case of positive rings, what happens? Positive effect, what happens? It is say the transfer of electron is away from an atom or substituent group attached to the conjugated system. Means if I have one OH group here, suppose if I have a OH group here, then in such case what happens? That the transfer of electron is away from an atom or substituent, means here this electron will be moving towards the benzene ring. Towards the ring it will move. So this type of effect is known as positive resonance. In case of inductive effect, what happens? You see, inductive effect, what happens? If a carbon is bonded to a halogen atom, this halogen is electronegative. This will be pulling the electron towards itself. Then in such case, what will happen? This bond will become weak. This bond will become weak. So as a result, this carbon, it will also try to drag electron from this carbon, the adjacent carbon. So in that case, due to the presence of this chlorine, this bond was already weak, but this bond is also getting weaker. So this phenomenon is known as inductive effect, means due to the presence of one, the other one is also affected. This is known as inductive effect. Then this effect decreases as the bond is moving further. Then next comes the electromeric transfer. Here what happens? There is a complete transfer of the double bond to another, means the adjacent atom. The two types of electromeric effect are there again. This is Placey effect and this is Placey effect, where this electron is completely transferred to the adjacent atom. You can see here this electron is completely transferred to this, and when this will be transferred, this hydrogen will come and form a bond, and the another one is negative. Here the pi bond are transferred to the atom, which do not get attached here in this case. Now the last topic of this one is the hyperconjugation. In case of hyperconjugation, what happens? This is the phenomenon of the movement of a sigma bonded hydrogen, means a single bonded hydrogen. When it sees that the adjacent carbon is not completely satisfied, it just transfers it one hydrogen to the another one. If you want more example, you can see the book, but here what I can tell you is that if these three carbons are there and if all of them are bonded to hydrogen, and if this carbon is not completely satisfied by the presence of four bonds, so what happens? The adjacent carbon, it loses one hydrogen and this hydrogen forms a bond with this one. This effect is known as hyperconjugation. Hyperconjugation is general stabilizing interaction. It involves delocalization of sigma electrons of CH bond of an alkyl group directly attached to an atom of unsaturated system or to an atom with unshared p orbital. Hyperconjugation is a permanent effect. Means in such case, what happens? If any adjacent carbon is not fully occupied, the carbon, it just loses its hydrogen and give it to the adjacent carbon. So with all this, I just end this chapter here, but this is not an end to this chapter. We'll be dealing more with all these topics once the class reopens, or we will be having some doubt clearing sessions in the Zoom classes in the coming days. So I just hope to meet you all through Zoom classes. Thank you for watching the video up to here. Thank you very much.